This project is a wearable shear-wave elastography device sponsored by Penn State Mechanical Engineering. Ultrasound elastography in the current market has the ability to assess the stiffness of a muscle while the patient is at rest. If this could be done while they are in motion, it could help provide more information to the extent of an injury and could possibly help the patient heal more quickly. So the goal of this project was to create a wearable device that could accomplish such functionality. It will be composed of 2 continuously transmitting and 2 receiving transducers, and a vibrating motor that will send out a shear wave whose speed through the muscle can be evaluated based on its arrival time at each set of transducers. The main components are 4 transducers, a vibrating motor, a pocket-sized oscilloscope, and the Raspberry Pi 4. The first phase of the project was testing how the transducers worked in different mediums such as deionized water, gelatin, and an agarose phantom. A 3-cycle burst at 1.7 MHz, which is the resonant frequency of the transducers, was sent every 100 microseconds into the transmitting transducer, and the response of the receiving transducer was observed on an oscilloscope. Throughout the process, we shifted to less equipment until we were able to operate through the Raspberry Pi wirelessly connected to the computer. The second phase was designing the mold for the motor and the transducers, which places them at an angle for better fit and signal reflection, and a casing to hold all the components together. For functionality, the user uses the Raspberry Pi desktop that is available on the laptop screen and generates the waves through the analog module that are sent through the phantom, reflect off the bottom, and are received by the paired transducers while the motor vibrates the phantom. Here's an example of a received signal with the delay representing the round-trip time of the signal through the phantom. As a whole, this device can be worn with the help of a lightweight vest, has the ability to sense ultrasonic signals, contains a vibrating motor that can send shear waves through a muscle, , allows the user to collect and store data from the oscilloscope readings. Future scope of the project would involve adding an amplifier to make the received signal more visible, as well as modifying the casings to provide neater feeding of the wires.